Why are there no working maps of flat Earth? So this is a debunking technique that Mick West started, and this is so unscientific. Now, it's a bit of a doozy, so that's why they use it, and that's why they push it so hard. But most flat earthers understand it, but it is a bit of a complex answer. But it's simple in nature that all maps are flat Earth maps. That's the answer. They project everything onto a plane, and they never show curvature when they map things out. They never show a curved line. They always invert it into a straight line, and they don't show in and out of the center of mass. They don't show curvature. Now, the tricky thing they do is they say, well, show me a scale, then show me a scale. The thing about maps is maps don't really use the scale that you think they're using. I know people think they do. When it comes to distances between the land and this Earth, it doesn't use map scales. It uses Dystrom's algorithm. It just does. If it's not Dystrom's, it's another algorithm, and it's based off of 4 distances. So once I know 2 distances, I can find another distance, and then once I know one common distance from the place I'm trying to find, I got everything. That's all I need to know. And that's what the algorithm says. And that's a bit complex. And you can go through that and you can learn that. But what the debunkers are doing is they're just tricking you by using this ball, and they're saying they're using the ball to map out all maps and find distances. They're absolutely not. The degrees of longitude and the degrees of latitude that you learned in school are then put on flat pieces of paper. Then they use equidistance. They use some algorithm to show you the distance. And it's a plane. They're using a car to drive on a road, but they're saying they're using a boat. They're saying it's a ball, but they're using a plane every time. And they'll go, well, it's just easier. It's just easier to use flat pieces of paper than carry balls around. No, I think you would need to show in and out of the center of mass. And this is what I believe Shaquille O'Neal was talking about when he was like, of course it's flat. I drive from Florida to Los Angeles like once a week. Like, I drive over a flat Earth. I get out of an airplane, I see it's flat. Oh, you guys can't handle it? Okay, haha, I'm not a flat earther, but the big Aristotle knows what's up. Because the big Aristotle, because he's smarter than everybody, and the big Aristotle knows you would be going in and out of a ball. It's curved, guys. Oh, wait, you never show curvature, ever. The globe proves you're not showing curvature. When I'm at the beach showing you that there's no curvature, you have to account for that distance using a curve. If you straighten that line out, now it's going to be a different distance because of its curve. So we got 25,000 miles in circumference on this ball, and the distance from one place to another place is in and out of this thing called the center of mass. And you're taking in and out of the center of mass, and you're straightening it out into a line. You're using our system. You're using planes. And then you go, why aren't there any flat Earth maps? Why aren't there any flat Earth maps? Every map is a flat Earth map, including this ball, because you can't use it to navigate. You can't find 2 distances on this ball without using a plane. You can't. You would think you would need a curved line if it were curved. Now, that can be impossible to comprehend, but it also can be impossible to comprehend that we live on a ball. And it's really that simple. Every map is a flat Earth map because every map uses straight lines, and straight lines don't show in and out of the center of mass. And distances are created by algorithms that show equidistant. They just take one distance, they find the distance of one place, and then they just go find the distance of another place, and then once they know enough distances, they can just compute it. Yeah, it's complicated. That one's a doozy, but you can kind of comprehend it. That's what they do. They're not using scales of a map. They're just using the distances of their algorithm, and every map is a flat Earth map, including Gleason's. Gleason's is the only world map that works, and yeah, those distances are absolutely fine. You just would plug in the distances. You could use his sun clock. You could also just use the Dijkstrom algorithm. It doesn't matter because you're using a flat piece of paper and you're not showing in and out of the center of mass and you're not accounting for curvature. Every map is a flat Earth map. That's all it is because the Earth is flat. And the maps prove it. Every single one, including this globe.